In this report, you'll learn what the objects around us are made of. Let's start! Atoms are the smallest building block of matter that can retain the chemical properties of an element. That means an atom of an element, let's say hydrogen, is the smallest amount of hydrogen that can exist. Because of the different types of atoms and the way they are arranged, different substances have different properties. However, substances are usually not found in atomic form, but in molecules or compounds. So, what are molecules? A molecule is a group of two or more atoms that are bonded together. Almost everything around us is made of molecules. How do we represent these molecules? We have two ways. First, using chemical formulas to show a molecule structure. Before we proceed, we need to know what chemical formulas are. A chemical formula is an abbreviated way of describing a molecule. There are three types. First is the molecular formula. It gives the exact number of atoms in a molecule. For example, hydrogen peroxide. A hydrogen peroxide molecule needs 2 hydrogen atoms and 2 oxygen atoms. Therefore, its molecular formula is H2O2. Second, empirical formula. It gives the ratio of atoms in a molecule. Same example, hydrogen peroxide, H2O2. We need to find the ratio of hydrogen atoms to the oxygen atoms. Since both have 2 atoms, we say 2 is 2. In lowest term, 1 is to 1. Therefore, its empirical formula is HO. And third, the structural formula. It is a graphical representation to show a molecule structure. The second way to represent molecules is through diagrams. Diagrams give us a representation of how the atoms are arranged in a molecule. There are 2 types of diagrams. First, ball and stick models. It is a 3-dimensional molecular model that uses balls to represent atoms and sticks to represent the bonds. Here is an example. And second, the space-filling model. It is also 3-dimensional, but atoms are represented by multicolored spheres and nothing is used to represent the bonds. Here is an example.
Intermolecular and intermolecular forces. When atoms join to form molecules, they are held together by chemical bonds. The type of bond and the strength of the bond depends on the atoms that are involved. These bonds are called intermolecular forces because they are bonding forces inside the molecule. Inter means within or inside. Simply, intermolecular force is a force between atoms of a molecule which holds them together. There are 3 types of intermolecular bonds: covalent, ionic, and metallic. Covalent bonds exist between non-metal atoms, for example, carbon and oxygen atoms in a molecule of carbon dioxide. Second, ionic bonds occur between non-metal and metal atoms, for example, sodium and chlorine atoms in a molecule of sodium chloride. Lastly, metallic bonds join metal atoms, for example, copper atoms in a piece of copper metal. On the other hand, intermolecular forces are those bonds that hold molecules together. For an instance, a glass of water contains numerous molecules. These molecules are held together by intermolecular forces. The strength of an intermolecular forces is important because they affect properties such as melting point and boiling point. The stronger the intermolecular forces, the higher the melting point and boiling point of the substance. The strength of the intermolecular forces increases, the size of the molecule increases. In other words, there is a directly proportional relationship between the two of them. Here is an illustration showing the intermolecular and intermolecular forces in water. To summarize everything we learned, there are 2 types of forces that hold matter together. With water as an example, there are intermolecular forces that hold the 2 hydrogen atoms, the oxygen atom in each molecule of water. Also, there is intermolecular forces between each of these water molecules. As mentioned earlier, these forces are very important because they affect many of the properties of matter such as boiling point, melting point, and a number of other properties. With that, there is an exercise that follows after this. Good luck and thank you.